Okay, in this section of the video, I'm going to show you how to simplify algebra problems. It's a little review, simplify expressions, distributive properties, and solving for unknowns. So first we're going to simplify. When you simplify, you have to first combine like terms. Like terms are terms with the same variable or numbers that stand alone. So in other words, for the first one, we have 3a plus 2a minus 7a plus 5. So the things that come to mind, the things that are like terms, are the ones with a's in it. And you have to be very mindful of all the signs in front of them. So the 3 has nothing in front of it, so it's positive, plus the 2 would be 5. And then when you subtract 7, you'll have 5a minus 7a. 5a minus 7a would be negative 2a plus 5. You cannot combine those two because the 2 has the a and the 5 has nothing, so those are combined, those terms. The next one is 14b minus 13c plus 17b minus 13c. Again, the key here is looking at your signs and looking at like terms. So we have two b's that are together, 14 and plus 17b, which would make it 31b. And with your c's, you have minus 13c and minus 13c again, so it would be minus 26c. Since one has a b and one has a c, you're done. Distributive property, again, we're going to have whatever number outside of the parentheses, you're going to multiply by each term in the side parentheses. So terms are separated by plus, minus, and equal signs. Here we go. We have your 5 here, and you're going to do the 5 times the 3x, and then you're going to do the 5 times the 2. So I have 5 times 3x plus 5 times 2. Be very mindful of signs. There were no negative signs in here, so we're pretty good. 5 times 3 would be 15x plus 10. And then you would be done because 15 has an x and 10 doesn't have anything. The next one you're going to do is take the 3 to both terms. So we have 3 times 2x minus 3 times 5. And then we still have that plus 1 by itself. We would not multiply the 3 by the 1 because the 1 was not in parentheses. When you multiply this out, you have 6x minus 15, and then you have to keep your plus 1 still. Now you still have terms that are like, because the 15 and the 1 don't have anything next to it, so we're going to combine those. Now remember, the 15 has a minus sign, so it's negative 15 plus 1 to get negative 14. Or minus 14. Next we have here is negative 2, and we're going to put it into everything in the parentheses. There are no parentheses here. It's separated by a minus sign, so I'm only going to work on this. So negative 2 times 4 would be negative 8x. Negative 2 times 7 would be negative 14. And now I'm going to work with the second set of parentheses, and I have the negative 1 times both. Because remember, nothing in front of a parentheses means there is a 1 implied. So I have a negative 1 times 3, which would be negative 3x, and a negative 1 times negative 1, which would be plus 1. When I add the like terms, I have negative 8x minus 3 more x would be negative 11x. And then I have negative 14 plus 1 to get minus 13. The next one here, 9 stands alone so far because we have the 3 touching the parentheses. So the 3 is going to get distributed to both terms inside. So I have 3 times 4 would be 12x, and a positive 3 times negative 10 would be minus 30. And when we combine like terms, the 9 minus 30 gives me a negative 21, and then I just have plus 12x. Keep in mind, if you did the 12x first, you could have 12x minus 21. The minus sign stayed in front of the 21, and the plus sign stayed in front of the x. So both are acceptable answers. Let's move on. Let's move on to solving equations. I'm going to work on this. When you solve equations using algebra, every time I see a fraction, I'm going to get rid of it by multiplying each term by the least common multiple, or divisor. So right now, I only have one fraction in here. So my fraction has a 4 in the denominator, so my LCD is 4. So I'm going to multiply each term by 4. Since that 1/4 is a fraction, I'm going to multiply 4 over 1 times 1/4 x minus 4. Since it's not a fraction, I'm going to keep it a whole number, equals, and I'm going to multiply the last thing by 4. So here, my 4's cancel, or I have 4 times 1 is 4 over 4. When they cancel, they become 1s, and I'm just left with 1x minus 20 equals 80. And now we can breathe. Because there are no fractions, it feels easier to do. Whatever I do to one side, I'm going to do to the other to get numbers on one side and letters on another. So I just have x equals 100. On this next one, I also have the same LCD, which is 4. So I'm going to multiply this by 4, but it's a fraction. So I'm going to multiply it by a fraction as well. And I'm going to multiply this by 4. Whatever I do to one term, I have to do to every term. When I multiply this, I could either cancel my 4's, or I can say 4 times 3 is 12 over 4. Either way, I have 3x equals 24. And to get x by itself, I have to divide by 3, and x equals 8. We already did this in Unit 1, so this is just a recap for Unit 4. For the distributive property, we're going to use it to solve equations as well. I'm going to multiply my 3 by my 2x and my 3 by my 3, so I have 6x plus 9 equals 5. And when I do the algebra, I'm going to subtract 9 from each side. So I have 6x equals negative 4. Ooh, move those down. When I divide by 6, I get x equals negative 4/6, which is actually negative 2/3, because I divided the 4 and the 6 by 2. And the last one I want to show you is 5. I'm going to multiply it by x, and I'm going to multiply it by negative 6. So I have 5x minus 30 equals 9. I have to get x by itself, so I'm going to add 30 to each side. And I have 5x equals 39. And when I divide by 5, I get x equals 39 over 5. You can also make that an improper fraction. 5 goes into 39 7 times with a remainder of 4. So it can also be 7 4/5. I know I'm going over this pretty quickly, but we also did this in Unit 1, so I just want to do a reminder of algebra. When we solve for unknowns, remember we have solved for t, so in other words, I have to get t by itself. In order to get t by itself, it's not attached with a plus or minus sign, it's attached with multiplication, so I have to divide to get rid of anything attached to t, and I just have d over r equals t. If I'm solving for w, that means I have to keep this on the side of the equation, so I'm going to keep this here, which means I have to get rid of my 2l. Since p's and l's don't mix, I'm going to have p minus 2l equals 2w. But again, I have to get w just by itself, so I'm going to divide by whatever is attached to it, and it's acceptable to just leave it as p minus 2l over 2. Solve for a. When I solve for a, I'm going to keep a on this side of the equation, and I'm going to get rid of my f, so I'm going to plus f. So I have 2a equals w plus f. And then since I'm solving for a, I'm going to divide by my 2, And it's acceptable just to leave it as A equals W plus F over 2. Awesome. So that recap was real quick for our algebra and distributive property section.